Yeah, hey Rahul. Hi, yeah. So we'll just wait for like 2 more minutes and then we'll give it to go. Let's see if anyone else joins.
Sounds good.
It seems like people will keep joining, but we'll give it a go now. So, all right, I hope you had a great weekend there. So let's move further. Now, see, we started with test case design techniques. And in that, we kind of went with equivalence partitioning and boundary value analysis, right? When we saw that how we can have, how we can avoid exhaustive testing by just going with only few of those available up in there itself, right? So now what do we have? Primarily, now the next technique that we have here is decision table testing. Now, decision table, what do we do is, see, earlier it was all about what value should have been there. Okay, right? Now, what do we have here is keeping that into consideration. Okay, now it is not just about decision table is all about how many possible combinations you can have for the values. And depending upon that, the flow will be going up. So let's say you have to provide a username, okay, and you have to enter a password, right? Now, when you click on to the next part, that is login, it will check, it will simply check that whether this is correct or not. And then accordingly, it will take you further, or whether it will show you a message that no, your username password is not correct. But we have two values here. So how many could be the total number of possible combinations for these two values based on to the correctness and incorrectness of this value, whether this is correct or not correct, right? And then how many combinations can be there? That is what, because see, if you will just check that, okay, if username is correct, I'll tell you, see how this actually works. Okay. Let's say we go with these different combinations here. Then what could be the, let's say if we do this manually, okay, without any technique, then how many of these could be there? Say we go like this. We say that, okay, uh, username and password, both are, let's say, not correct. Okay, then what happens? What if the username is correct, password is not correct? Username is not correct, password is correct. Username and password both are correct. Then what happens? Can we have any more such combination? Now, if you do this manually, you'll see that, okay, we got these four. Can we have more or not? Is there any guarantee that you're done with all the possible combinations? There is no guarantee. Plus, is there any guarantee that you're not repeating? See, right now, this is just two. Input fields. But then it's going to be more. So now to do this, we have something known as decision table testing. Now, how do we go with this decision table testing here is, now decision table testing primarily talk about this. You have to create a table. That table will primarily be having this conditions. Conditions would be your inputs, and then based on to that, based on to the correctness and incorrectness, what could be the output? This input you have to figure it out. Output you will have in the requirements. And then based on to that, you have to create these columns. Now these columns are not fixed. How would you know that there will be this many combinations or this many combinations? So that actually they have came up with, see, let's say if I create it like this. So how would I know that there will be four? Because I only created this that okay, my conditions would be I have a username and I have a password, and based on to that there will be some output. But how many columns should I draw? Get your columns. There is a mathematical formula which says that let's say if n is equal to 2 is there, or you can say if n is equal to number of values, okay, then your number of columns would be 2 is raised to the power n. I'll say, okay, 2 is raised to the power n. What is n here? 2. That is my number of values. And if I say 2 is raised to the power 2, that would be 2 multiplied by 2. That would be 4. So for two values, there can be total 4 possible combinations of values. So that, okay, based on to this, if we create 4 columns, then it would be something like this. So this formula gives you number of columns. We'll do for more values as well. But right now for 2, we get this here. Okay. Now, but how would you fill up these values here? Like whether the value is correct or not correct. Now for that, there is a trick that you need to follow. That trick says that you can go with false, true, false, true. Go with, start with the first row. Go with one false, one true, one false, one true, one false, one true, like this. And then double it up. So when you double it up, it goes with two false, two true. One false, one true, one false, one true, then doubling it up, two false, two false, two true, like that. Okay. And then based on to these two values, you can put up the output depending upon what it is mentioned in the requirement. If the requirement says that, okay, there will be a successful login, which we are calling it as H. H means home screen is displayed. So you are successfully logged in. If they say that your successful login is there only if username, password both are correct. Otherwise, if both of these are not correct, then there will be an error message. If password is not correct, then also there will be an error message. If username is not correct, then also there will be an error message. So that's how you got this complete. Now also that okay, We got a formula. Using that formula, we're able to create the table. Using this trick, we're able to fill up the values as well. But we're not here to play around with creating a colorful table. No, right? Our agenda was to create a test case. Where is the test case out of it? Okay. So for that, you can use this particular interpretation for your test case. Now, how does this work here is what you would see here is that, see, your because when you have to create a test case, what you would need? You would need what you have to test, steps, data, and the expected result. Because right now, what we're doing, we are designing a test case. Designing only goes till here. This is designing because this is all about testing. This is designing. That is executing. So designing the test case, you need to have these details. Are we getting these details out of it? Yes. See, what you have to test, I have to test if I have correct data. So in this case, I don't have that. So I'll say, what if the checking the customer with invalid data, right? Then you need data steps. You can figure it out. Data you will get here that both are wrong values. Okay. And then expected output. What is the expected output? User is shown with an error message that you can't log in or please provide correct credentials. Something like this. That would be right. That's how it's going to go with this. Okay. Then you have these two. Just similarly, if username was correct, password was wrong, so you can have these two values, two different values this time. Okay. So you can create like 4 test cases depending upon these values. Now, so that, okay, we created, but what's the advantage? The advantage here is that rather than figuring out manually, you got all the possible combinations and correct combinations. Those could be there for these two. That is how it will be all going in. That is how it all goes up. That. Now you'd say that, okay, we got this up in here. Where we should go with the next one. Now I'll tell you how we would go with the next one. I'll tell you how you can go with that. Now, what we would go with more of those is, I'll tell you. Now, let's say, what if we got this for 2? What if we have more? Like, let's say, if the number of values here is 3, how? Let's say we go with this. Let's say we got one more value. Now, what you would do with that? One more value. Now, how many combinations will be there? We have a simple formula. Now, in this case, n becomes 3. So, number of columns would be 2 is raised to the power 3. That is 2 multiplied by 2 multiplied by 2. That is 8. That would be your number of columns. So, how would that appear here? 8. So, if I try to create 8 here, it would look something like this. Let's say if I delete the values for now. So this is how exactly it looks like. Right? We have roles, username and password. It's okay. We can have role on top and then username and password. That doesn't matter. Ultimately, the agenda is that we need to cover all the possible combinations of these values. Now, okay, we got 8. So which means there cannot be more than 8 values for this, for sure. Okay, there can't be more than that. So for this now, what we would do is we will go with this. With that, We'll go with this. Now, how will you fill up the values in this? Again, the same trick. How do you fill up the values? You'll go with one false, one true, one false, one true, one false, one true, one false, one true. Then you'll go with two false, two true, two false, two true. And then I told you that as you move further, just keep doubling it up. You go with two false, two true, you're done with. Now I'll go with four false. Now these combinations of the values that you're seeing here, this is actually this one. Can't have more than that. You would be having in here. Okay? Can't have more than that. There cannot be any more possible combination that you can have for these values. And based on that, you can simply put in like in your requirement, if it says that, okay, if this is like, it should be all errors until unless each of these are true, then you can go with this type of output. If they say that no, if any two values are correct, we will allow you in, then you can go like this. Depends what your requirement says. So if your requirement says that no, that's all how it is going to be, right? Then you can go accordingly. That is how it does go.
So, to finish understanding this, we're going to make a decision tree. So it's 2 to the n based on how many fields we have to enter. If there's 3 fields, then it's 2 to the 3.
Yeah, you can say that. Yes.
And then initially we'll start by first it's always false. It's
Hmm.
always false and always true. And then we duplicate that to the right, and then we keep doubling that. It'll be false, false, then 2 true, then 4 false and 4 true after that.
Yes, even like if you have, let's say, in these case we had these values. Let's say now, how about if you have four values? If your number of
Yeah.
values are four, then it will go like 2 raised to the power 4, which will be like 2 multiplied by 2 multiplied by 2 multiplied by 2. And that way you can have 16. So for that, it's gonna be like this. But like you will
Okay.
be able to create, see, with this formula, you can only get the number of columns. But to fill in the values, you have to follow that concept that I told you, like one false, one true,
One
one.
false, one true. Then you keep
Uh,
doubling that
keep
the
doing
entire
that.
time.
Yes. Keep doing that and then keep doubling that. And you will get all the unique possible combinations that you could think of for these my number of values, because this is all based onto the binary. So that's why all these possible combinations would be all unique and quickly you can create. Imagine you doing this manually. It's going to take like hours just to calculate that, okay, how many possible combinations can be there. But here it's taking like less than a
Yeah.
minute to
It's
get.
just 2 to the n. And then so it's only true if and only if all of them are true. That's how we'll know it
Depends.
passes all the cases.
Depends. This output actually depends based on to your requirement. If your requirement
Okay.
says that any two values are correct, then you can make them in. then you can have that, like have this edge appearing in here, or if this output all depends upon the requirements, like
Okay.
how many
But the
values.
premise still stands the entire time.
Yes,
It's pretty much
yes,
the same formula.
yes. Table will be there, right? So we needed something that we can figure it out how many columns will be there and how to fill in values to create all different unique combinations, all possible unique combinations for these values. That is what we were able to create. Because let's say right now we are doing this as a QA, as a tester. Now we need to make sure that the user cannot come up with anything beyond this. And the user actually can't come up with anything beyond this because this is all being calculated with math. And math gives you like everything exact here. That's how it is.
Okay, I got it.
Right. So this is going to be your like how do you go with this one? This is okay. Next, what do we have is we're gonna go with the next testing, which is state transition table. Now, what happens with the state transition table? Here is in this case, we are going to create a state transition table. Now, that state transition table, you might get it. Right, primarily in this, or you may need to create this. I'll tell you. Now for this, what we would do is we will go with this time a state transition diagram. Now, what the state transition diagram is all about? They create a diagram wherein, let's say, there's a process. In that process, there are different states. Now, those states are depending upon different types of values. Now, and in all of these state transition diagrams, you will have one as the start state, and there will be few of these finish states. Okay. So in these finish states, depending upon the inputs, and based on to that, actually, you would create a state transition table. Now, this diagram could be part of the document created by BAs for you. Okay. That's how it's all going to be. Now, what happens in this case now? Generally, onto the start, you won't provide any inputs. From the start, you'll be always go with the first state. And then there, based on to the inputs provided, you will get to the next stage or final state, depending upon what is the input. So let's say you're in a native machine, you go with the first try, enter the correct pin, you'll be granted access. That's it. That's where this process ends. But let's say if you're entering incorrect pin, then you'll be given a second attempt. Second attempt, you go with correct pin, then access granted. But in the second attempt also, you're going with incorrect pin, then you'll be given a third attempt also. Third attempt, correct pin, access granted. But in the third attempt also, if you're going with an incorrect pin, your account will be blocked. Now, these states will be then depending upon the requirements. That account is blocked or user is blocked or account is blocked for 24 hours only, something like that. Depends how it is there. This actually helps you to understand your requirement in a more clear way. You can come up with some clear test cases. And for that, you can create this type of state transition table where you can first define these states. You can just name those states that, okay, these are my six states, S1, S2, S3, S4, S5, S6, right? And then you can provide inputs. Inputs, we have two inputs, correct pin or incorrect pin. Based on to that, what would be the transition to the next state? That is what we have to put up here. Now, I told you that start and finish states, you will not provide any inputs, right? So you'll simply start with the state number two, first attempt. So first attempt, correct pin, state five, access granted. First attempt, incorrect pin, state three, second attempt. Second attempt, correct pin, state five, access granted. Second attempt, incorrect pin, state four, third attempt. Third attempt, correct pin, state five, access granted. Third attempt, incorrect pin, state six, unlocked. So now this actually is giving us a detailed insights onto what would happen when. And this would help you to have all of those completely available up in here. That is what it will help you with this. Right? And there we will go with this. That is how it all goes up here. This we are kind of getting in all of these, like more clarity into the requirement with this. So these actually, see, more clarity we'll have towards the requirements, more precise, more accurate our test cases would be. That's where it all goes up with this. Similarly, we have one more wherein you can call it as a use case testing that actually you do based on to the use case diagram. So use case diagram, if you remember, it is all about who will do what in this system. Or if you are just going with a process, then in that process, right? So you can see this is a different use case here where let's say we're trying to log in. So we have two responsive entities. One is actor, another one is system. Actor could be your user. Okay. Now this user will enter the username and password. System will validate the password. And if everything goes well, system will allow the account access. This is your normal flow, regular flow. Okay. But what if while validating this password, there could be two different scenarios. If everything goes well, we allowed account access. But if the password is not valid, then it will display an error message that asks for retry 3 times. So password not valid, please re-enter the password. Then again you'll go there. Again it will validate. Again not valid, retry. Again it will enter. Again it will not valid, retry. 3 times it will ask you to retry. Fourth time also, if it is not wrong, then it will come back here. Not valid 3 times, it can go through. In fact, onto your third time itself. Only 2 times it's going to ask you to retry. Third time, if it doesn't do that, it will simply close the application. That is how it all goes on. Yes. Right, so this is going to be the use case testing. Just to have more and more clarity onto these details of here. That is how we can go with that. And that's what like they have mentioned here as well. State transition and use case. These are primarily the techniques which actually can be used up in here. This. Now, when we go ahead with these structure based, now structure based are not primarily for you. These are primarily for the programmers who are actually performing white box testing because they need to deal with the code. So, how they can check the performance of the code, that is what they're going to do with the structure based test case design techniques. Because in this, they will actually analyze the quality of the code, like code coverage, readability, maintainability, security, bug vulnerability, reusability. That is all what they're going to do in here. Now, with this, you have a statement testing technique wherein what they can do is they can check like individual statement, then they can check like decision. So there are different conditions that they will check based on to that condition. They'll see that, okay, where it will just do this or it will go to the next part. Then they might be using condition testing where they'll simply check whether the condition will result in true or false. They can even have multiple condition testing techniques when there are multiple conditions in a single statement. And then they'll check for that, like what if someone will do on Monday, Tuesday, Wednesday, Thursday, or they can have like multiple conditions available there in a same statement that they will discuss. Path testing also they can do to check the independent executable paths. Like let's say, what if the user goes towards men's section in an online shopping. So log in men's section and then shoes and then likewise. Okay, so what could be the different parts of execution in an application? So that way they go with the path testing up in here itself. This is all about the white box. Since you will be not involved into that, so there is no point having discussion onto that as well. Now comes experience based. Experience based, if we talk about, it is all about, people having more and more of experience, right? Now, how do we go with that here is, we'll go with experience based. This actually is for those where we have these weeks. Yeah, going with more of those, what do you call as, people who are having experience. First technique they use is error guessing. So they can, since they have, years of experience with that, right? So they can actually foresee those errors. That okay, if this is the place, then like there will be multiple of these errors which could be there. Okay, right? Then based on to that, what you can have is you can actually have this. They can check that okay, this is the model, this is how it all goes with. Okay, and that's where it all comes up with this. Okay, even in that case, how it would go with this up in here is error guessing and exploratory testing. For exploratory testing, what you could do is they will be simply go with saying that they will explore the application and at the same time, they will write the test cases. That's how it would be in here, in this, primarily with that. we will have it going in here. It will tell you that how exactly it would be going with this. So they can identify those critical bugs because at this time they don't do it. They don't create the test cases in advance. No, they will simply go and check that up in there, and they'll see that okay, if this is there, then they will write the test cases and they'll execute the test cases immediately by looking at the application itself based on their experience. Because this is primarily for those folks who are having like 5, 10, 15, 20 years of experience, right? To identify all those critical bugs, which are not there, of course, because of that, the way we go with this one. Now, traceability matrix, let me open one quickly as well, because traceability matrix, I have shared that with you already. Yeah, let me just share my screen. Now, traceability matrix actually goes with going that up in here, saying that, okay, you can actually trace down the requirements. Requirements and their implementation as a functionality, because this is what software development is all about, right? We discussed this earlier as well. This is just a topic which talks about that you have requirement traceability matrix where it is capturing all the requirements, and it will check whether those requirements are implemented as a feature or functionality in the application or not. How? By the status of their test case execution. If test case execution is going well, then it is a functionality now, that requirement. But if there are any issues, then it is an error that needs to be reported. And that's what like they have up in here itself. Now in this also we have types of traceability matrix, right? One we have forward traceability, which will be going like forward from here to here. Like from test cases to the mapping of test cases to the requirements to the test cases. Another one we have, so if there are any changes in the requirements, that would trigger the changes in the test cases. Backward is all about, let's say, if there are any problems uh, detected in the test cases, those would trigger to the requirements as well. That is what it could be. But nowadays, primarily we go with bidirectional. When they say that, okay, wherever you have, because ultimately the agenda here is to get the users more and more clearly up in here. So they say that, okay, rather than going with this, what you can do is you primarily go with wherever the issue is, you need to make those things going up with that. Here it's right. That is how it would go. And that's why, like with this, we get a lot of advantages that it helps you to, 100% test coverage that you get in here, right? More than that, it will highlight if there are any document inconsistencies because you'll have that document also in place, right? At the same time, it will give you the overall defects and execution status because that's what you can see in that particular document. Okay. And the analyzing and estimating the impact, like how many of those will be there or not. That's how it would be with these. It would go primarily into that itself. This up in here, right? So keeping that into consideration, we can see that, okay, these are the RTM document that we primarily see up in there. I believe I have shared this with you. Just in case, if not, I'm just going to put that in the chat again, this document. And this primarily will this case designed to me. Next, actually, what we're going to do is we would be discussing next we'll start with this one. SQL, but that will start tomorrow. Okay. This is what we have for the day. Any questions before we call it today? Oh,
No, I'm good.
all right, then, yeah. Have a great night and see you tomorrow.
All right. You have a good night.